I am just finished up with lunch. Got one quick thing I'm going to step out for a few minutes. Not even a few minutes, a minute or two. But let's get going again. So we were talking about Bundler and the work we've done to make it incremental. And I have it running right now, although I haven't actually confirmed that it's correctly incremental. So that's the next thing we're going to do here. Make sure that we are only updating the things that change. And this is just about useless on a project the size that we're looking at here. There's only 2 Java files, and there's 2 JavaScript files. Each of these will explode into a whole 2 JavaScript files, so a total of 6 JavaScript files across the entire project. So it doesn't really have a lot of work to do to sort all that stuff, but it would still be nice to confirm that we are incremental here, and then see about scaling this up to something much, much larger. So I've got a debugger here. Just grab that real quick and say maven ops equals, put that in there, and then run the same command as last time. Now we want to do a little bit of logging in here and make sure that we are incremental. So we added this incremental enabled flag, right? We can ask the configuration, is incremental enabled? And this is intended to be a way of allowing some tasks to opt in if they want to, if they have to do some actual work to do that. Now, this isn't the kind of task where we have real heavy lifting to do to get it to be incremental. It's nothing as bad as running Java C or a Jackal, for example, because all the metadata we need anyway to incrementally build is already available. If you just do a normal build, you already have to build all the dependency information. It's going to do it anyway if you do it the old way. All we're going to do now is say, okay, go ahead and sort it, and then do the bundle work, and then also dump the incremental. Sorry, this is the bundle work. Where do we dump? Yeah, here we go. And this is where we just dump the dependency info that we discovered to disk. So even a normal startup is gonna just say, well, from cold startup, we've detected that you built recently. We figured out what dependency info existed already. So let's go ahead and figure this out. So let's do a quick bit of logging here. I've got the debugger attached. No, not yet. Now it's attached. We can say, okay, if incremental is enabled, and there was already something present, then we can go ahead and run this. Now, if incremental is disabled, that means we'll skip this, but we'll still write the dependency info. If incremental is then later enabled, we can use that last build to keep going here. And this is especially important in the case of a dependency that doesn't change very often in your project. If you've had incremental off and then you turn it back on again, we can go ahead and run it incrementally. We can say, oh, okay, I detected only one file has changed. You last built this forever ago, nothing has changed, and then you turned incremental on after a week or two, and then a week or two later a change happened. We don't want to force you on the slow path just because of that decision you made before, especially since it costs us practically nothing to dump all this output to disk. Granted, it does cost something. There is something we're going to do here. So let's look as we go through here and figure out, we'll read the old information off disk, and then before we start iterating through and deciding what kind of change happened, we'll put this breakpoint and take a look at each change and examine what changes it makes to our output. So let's go and modify hello world to replace one of our exclamation points with a 1, like you do. And here we are. We're in here. We're saying what actually has changed. The change we're looking at here is the hello world impl Java was modified, which means our old dependency info is likely inaccurate. Now, this isn't the most efficient way of detecting that our dependency info has changed. Really what we want to do is actually collect the dependency info, and as you collect it, compare it to the old one. That would be even better. Take the old graph, take the new graph. Okay, if they're the same, then we actually have no change to make here at all. Unfortunately, to do that, we would have to make it a separate task that would collect dependency info in one task, and then a second one would do the building. So go through and collect all the dependency info, write it all to disk, and then another task that that reads the dependency info, but also reads the actual JS files, and figures out, nope, I'm wrong, this wouldn't make sense. Nope, I'm sorry, this wouldn't make sense. Because if the files themselves changed, the contents change in a way that doesn't alter dependencies, we still have to update the bundles. So we're going to go through and we're going to say I modified one thing here, so I'm going to go ahead and replace it with a new one. We've got a new compiler input, and then we are going to create a new dependency info. So of our 6 files, one of them is changed, and now a second one is, oh, only one changed. The other one is the same. Okay, so this makes sense. If a single Java file if a single Java file is compiled into 2 JavaScript files, the first one is just the dependencies that we have that we use to hook up circular dependencies and things like that. The other one is the actual contents of the methods and things like that. So it's only the contents of the methods here that have changed. So only one single file changed. Now that we've finished that work, okay, we've got another input. We're looking at what is our other input. JS contained 2 inputs. Let's see what this other one is. They seem to be the same. Hello world, single output type, transpiled. Okay, in bytecode. So this one probably actually has no contents at all. Yep, it has nothing at all. So nothing has changed in it that we need to keep track of. So we don't update our graph at all. We just carry on here and say, okay, now I have built my map of all my dependency info, and now we will incrementally sort it. Done. Of course, 6 files, doesn't take very long to sort. And then we will go ahead and build this. Now this we worked out 2 or so weeks ago to say, what do we need here? What is the default that Clojure compiler itself does when constructing a bundler? And this is what we extracted. We said there's a null transpiler, and there's a specific transpiler just for the sake of ES6 needs to be compiled down without modules. We need to remove the modules. We're going to build it for resolution mode in the browser, which refers to what do our import statements look like. I'm not exactly sure what implications this has, but I can definitively say that it doesn't matter in our case. We don't need to worry about this. And then we grab all the JS files, we have all their paths, and we just need to reorder them into one big output. Now, if other files did not change, there could potentially be efficient ways of replacing the contents in the output file of only the one that did change. It turns out that's a little bit messy. And then this runtime library name is always this empty string constant for some reason. We use eval true because it enables us to specify source URLs. So once we've got a bundler, unfortunately the bundler has to close over our JS input. So we have to create a new one every time, which means we have to create a base transpiler every time because it needs to have the JS as input. The arguments for base transpilers you can see go all the way up to here. But nothing else changes. It's only this collection of paths that change. And I don't believe it's possible to modify a base transpiler to have a new compiler supplier. Let's see. I don't think it's possible to change this to have a new set of sources. Whatever you got or what you got, forever. So, but that's worth looking at real quick. Is it the module roots? Let's see, we get the parent paths, which is the roots we started from. Yeah, and those roots are going to change because it's the different cache directory you read each time. If we did this more like Gradle, where we just had directories that you weren't supposed to touch in your build stuff, and we had some caching thing, I don't know how clever they get, but that was just a little more messing around that I really wanted to get involved in. Let's see, the compiler supplier module roots is an immutable list. And all we do is we tweak the options every time we make a new one. So in theory, we could just replace the compiler supplier with our own compiler supplier, and then just call set module roots each time. In practice, the rest of the cost of all this is negligible. This is the only thing that actually costs anything to set up. So it's just some extra object allocations we're paying for. Okay, let's step on past this, because none of this is interesting now that we understand what it is. All right, so now we are going to generate an output file, which is going to be our, that name doesn't look right. Let's make sure it's actually correct here. That's the output directory. the output file is too long to see, but it does have an extra JS on the end of it. We just can't see it here. The tooltip just is missing the .js at the very end. So we don't worry about it. Anyway, we're going to build an output stream. We're going to make a buffered writer on an output stream to that for UTF-8. There's probably a better way to do this. I'm using files new output stream, though, because in theory, that's going to be a more efficient way to write. And then we're going to say, okay, for each dependency info and source, which is our own custom dependency info type, in its sorted order, we're going to extract the code that belongs in that file and the name of that file. The name of the file is useful for some debugging to say, hey, where did this actually get from? Yeah, it's just like yesterday. Didn't get the notification yesterday when you came back on again for some reason. I don't know if it's because it's the same day. I thought it was because I left the screen up from here earlier streaming. Anyway, so you can see here that code contains the full, it's hard to read here. Do it here. Is that going to be any good at all? Nope, it's off the screen for you. Anyway, code contains the contents of the file. So this is the part where it reads it from disk. It turns out that if you already had to parse it here, up here, if you had to do this incrementally and detect that it was an added or a modified file, we already had to parse it. So we can just go ahead and fetch the same code again. We don't need to read it into memory a second time. It's already in memory. So if the code is not empty and the fill file name is not, or the file name is not, ends with fill file, we'll continue. So we don't, I think, need this because we don't do that kind of a setup here to do chunking. We don't do any chunking yet in our bundle code. I don't think we ever will. It's probably a little more hassle than we want to get into. The code is empty. Yeah, it's worth checking that, I guess. It might be nice to say, oh no, I added your file like you requested. It's just useless, and get these points here. And then we just say, okay, here is where your bundle out is going to be. We're going to put the path, this nice human readable path, which tells you where in your source it belonged, not where on the file system that I find it. This is an improvement over the old system. And then we will say, okay, hey bundler, I've got something with this path. The source URL happens to equal the path. That's just how we're going to use it. And then here's the code I've got and the dependency info, just in case you need to write it. Now the append to here is the only interesting part of this. Step in to append out. We're going to ask the dependency info, hey, was it a Google module? In which case, we append it in a special way, which is to say we just wrap it all up in a special call that says, I am now a Google module, and so I will interact programmatically with the module system, because there's special calls like goog.module and goog.require and goog.module.get that will work to go get the dependencies you need. If you were an ES6 module, we have to transpile your code, though. Say, how do I rewrite your exports and imports? Meetings, huh? And then if you're not either kind of module, then we just go ahead and append it in the traditional way, which is just to say concatenate it all in there. Now, we don't quite just plain concatenate it in there. We eval it because that gives us the source map trickery to say, hey, here's where you're going to go to find the original file for that path. Yes, the original path for that file. That way your source maps will work properly if you happen to have it. And it gives your debugger the ability to say, okay, well, what source would that have been? And then we stick a new line in there. I'm not totally sure that this is necessary because I'm getting 2 new lines between each file. That might just be a facet of how Jackal is emitting its output. Let's go all the way to the beginning here. Oh, we're not getting 2 new. We are getting 2 new lines, yeah. So the Goog module gets 1 new line, and then we put 1 extra new line. It only costs us a byte. It's just a little more readable to say, hey, where did each one of these things come from, to make sure they're vaguely in the right order. And then we've got the bigger, more complicated, scary ones, like, let's see, this is the bootstrap itself, which is the contents of, nope, that's not correct. Bootstrap. What did I do wrong? Results, sources, dependency info. Are there no sources? What did I do wrong here? Yeah, there we go. Okay. It just was out of date. So we have Goog base.js here. Can we wrap that line or just go to line? Here we go. We've got each of the other JS files that we need from Clojure itself. Now we do this extra wrapping thing because of, I think that is, I think this is a regular JS thing, just to say, hey, here's how we're going to call eval because of some concern about calling eval. Make sure it's very, very safe. It allows some browsers to stick an extra check in there to make sure that it's sane. I believe we actually have to have an extra little bit of JavaScript to say, hey, here's how you're going to load this. So this is the one file that loads all the other bundles into one big thing then. And the things it has to do are, first of all, bake in your defines, whatever those happen to be. And then we've got this little script here, an IIFE, just to keep all of its other globals from sneaking out, which will say which file do you grab, hash name and all, what order they need to be in, and then insert each one as a script tag. So by itself, if you don't bundle these things, every single JS file that would normally be bundled gets its own script tag in your page. And that turns out to be prohibitive. I suspect we will reach a point in some projects where they have thousands of jars being baked into a project, and that might be too expensive, and at that point we'll have to propose some other options for doing that. But I think that's a long ways off, so we haven't worried too much about that. And then we hook up some polyfills, some automatic polyfills that we might want later, so we just go ahead and add them unconditionally. And these polyfills will include some ES6 stuff to make sure that any eventual ES6 module works. And it also includes the eval prefilter, which is going to be take a string, return a string. Great. I'm glad we had this chat. There's also this extra little bit of glue for this trusted type thing. Apparently we directly call eval for that to say, if you're Chrome 87, we do this. I don't know why Google wants to have Chrome 87 checks still baked into every Clojure build. I asked if we could roll that back. They said, nope, we need it. Don't ever think about removing it. And in that case, we replace this with a particular bind script. So maybe it's that the check here is bogus, and it's not actually checking for Chrome 87. It's checking for Chrome 87 plus. That's my best guess about this trusted types empty scripting. Let's experiment real quick. Pull up Chromium. What's the code going to be? Trusted types.empty script. I want the console tab just a little smaller so I can read both parts at once. There we go. Okay, so that's a string. If you eval that, does it not equal trusted types empty script? Refuse to eval a string as JavaScript because unsafe eval is not allowed. That's surprising. If it's trusted, why wouldn't it be allowed? Admittedly, I'm not really good at how CSP stuff works, so that might be just my own limitations there. I'm surprised about that, though. It should just check to see if those are the same. I guess we could probably load it from the real page if we can get that working. Okay. Anyway, so that's the rest of our polyfill junk. That'll make this magic all happen. And back here again, finish stepping over. I guess we've got to write each file, so that's going to be 6 times through this. All right. And then we're in this breakpoint here of making sure load flags are set properly. We're going to write this JSON to disk. So we took the sorter, we took the sorted list, and then we mapped it into our on-disk format, which right now is just JSON. We may move to protobuf or something like that in the future. And then we will go ahead and write all that to disk. That way we can say, hey, next time you boot up, try and use this instead. Then we hash the output file, and we rename the file to that hash. That way, oh boy, it's going to go through the whole thing this way. I wonder if there's a quicker way we should be doing this. Input string read just byte chunks at a time? Probably. We'll think about that later. Anyway, it's going to rename the file to a hash version of the file name. That way you can just keep copying new files and replacing the old ones rather than deleting any old. It's not going to replace it, it's just going to append to it. It's going to make a new file and leave the old one alone. So we can do a little bit of timing information here and say what did it take before. It's not going to be very helpful in this case, but that's the kind of logging we could get here. And then if we make a new tab here, a new console, and cd into Shackle Maven plugin, target IT test, hello world single, and then do a python.m http.server. We already have it in use. Another window. Okay. Now, and I don't see any errors here. And it seems to have loaded each file. So something might be wrong, or I might have just done something dumb. Let's not discount that possibility. If we ask for sources, it is going to tell us where they are in the example directory, because it's already broken them up to say, hey, well, what is this? app.js, unable to fetch script source. Okay, so our source maps are not loading properly. Some of them are, some of them are not. That may be my fault, because we only changed this file, so it makes sense that these might not have gotten, well, these got copied over. That's a little weird. Oh, and this blew up an error. Did we do something dumb here? Failed to execute write on document. It's not possible to write. So it should have thrown, I guess. Unless an async loaded external script unless it is explicitly opened. Okay, so the problem here is that when we run in this way using the bundler, we have multiple JavaScript files, and we have to load each one as a separate file. And that means that we have to load it async. So we are going to need to change the code a little bit here. I mean, this is a bad practice anyway. We shouldn't do a document.write. I don't know why Google decided that that was the best way to approach this. But whatever, we can change that, and we can even get the autocomplete bit to show us what should happen. Document.write. So instead we're going to do a document.body.append. Append can actually take a string. There we go, save. Hey, it's saying, oh, let me autocomplete. Let me incrementally build for you. And then we'll say, just go ahead and continue. We turn off our breakpoints. And here we go. We get our message there. So this is working now. I am curious about what broke about these other files. Okay, it seemed to be back now. It might have just been something squirrely about the HTTP server here. Because it is just a Python HTTP server. It's singly threaded. It's got all kinds of other warts. Yeah, so I'm betting if we turn on source maps now that we can actually debug the Java directly. Because there is no Java in here, it shows. I usually have source maps off because I don't find them to be worthwhile most of the time. I usually just want to see the plain JavaScript. But that's because I usually am debugging things a little differently than a lot of other developers. Where is the source map button? Did I just miss it? Console, nope, extension, network, performance, sources, enable source maps. It's pulling down all those source maps. Some of them were not found properly. Let's try reloading this. It does not look like they're finding them properly. So we might have done something silly here. There's that. Here's this, hello world.java. It actually says the source map itself can't be found. Now, granted, it's got a lot of other things that can't be found, like internals of Bazel, which we shouldn't care about. I'm kind of surprised they get baked into the regular JRE, but here we are. It's the hello world itself that looks like it's missing. Hello world JS map. Oh, right. This is because because it is loading relative to, well, no, there should be a source URL in here. Okay, so we actually broke this. This is not just an irritating Chrome feature. We need to actually fix this path. Because if we look at the generated output here, it says that the file is other.jsmap, but we actually want the source URL to start with source. We don't want to just dump all of the sources into the same directory where your Bootstrap JavaScript file goes. Be right back. 1 second, please. So this is my call, okay? Snow day. Kid is home and not napping because she's a 6-year-old, and 6-year-olds don't take naps anymore. But just need a little bit of cool down time to make sure the day goes properly. All right, so we screwed up a path here. The closure bundle task should be building this with the expected path name, and we goofed. I think it's supposed to be here, the source URL. This is where we need to change this to specify, hey, it's actually in sources. Because in fact, we copy sources. I think we make some assumptions about where sources will go. Let's see, did the old code assume that? Let's look at the old code. All right, we are working on this closure bundle task. Here's the old one. Okay, so there's a path here, closure sources directory name. And we used to copy all of our output into that sources directory. That way we built from there relative to our own output, because that way Closure knew where the sources were going to end up. I'm not totally sure we care anymore. I think we can set our own variables about that. We just need to make sure that the sources directory is correctly populated, which is not a given anymore. So let's see here. If we go into here and check cache for our last build, so we're going to determine what the last build was by looking at this bundled.js directory. Make sure we got the latest files. 192. These are numbered numerically, right? Ordered numerically. There we go. 192. They're not. They're not. Now we want to check out if all the sources were updated here. They all seem to be here. And they are in a subdirectory called sources. So I wonder if that's actually necessary at this point. It looks like it knew at some point what the source URL was going to be, but I think we just need to plop it in here, because we want to display visibly in each bundle which file it came from. You know, some other dependency had this at this particular path. But when we get to the source URL name, we want to make sure that we are inside the sources directory. So here's where we're going to say something like closure.sources directory name // We don't care about Windows. Not because it won't work on Windows, but because we're running from a browser, and browsers say, sorry, we're going to use slashes. That's just what's going to happen. All right, so this is now our source name. That's going to behave properly here. In a perfect world, we would actually escape this, because then you could escape out of this thing here with a new line or something. So, but I'm not really going to worry about that. And I also wonder if we shouldn't say, hey, as long as we're dumping this thing, let's put the jar name at the top of it. Nah, that shouldn't matter because we already have the jar name as the name of the file. I mean, this is com.vertispan jackal bootstrap. It knows what version it was. It knows it was a JS zip too. All those things are already included in here. So we shouldn't need to do anything special. So let's just try that one little change. And then, no. Do I have more than one tab here going, or what do I have? Yeah, that's probably this tab. Yeah, this is it. Did I stay in the correct directory here? Let's put that back so we can run the server again. And here's where we're going to say build everything, but only run the tests for Hello World single, because we want a quick example to test with and verify with. Well, good news for the 6-year-old. Pajama Day, which was supposed to be tomorrow, has been rescheduled to after the new year. All right, we can stop in here. We don't need to wait for this part. This is just for, hey, our other stuff like the archetypes, are they working properly? Okay, so let's go back into the directory and run watch. We don't need the debugger, but it's not going to pause and wait for it, so that's fine. We can just use that line again. All right. So this has been reverted back to the old build. Oh, we don't even have the server running. There we go. Oh, you are a jerk. Why is this suddenly breaking? No such file or directory. Oh, I see. Because the directory was deleted and recreated. Now it exists. We were pointing at an inode that no longer existed. Okay, so now it's grabbing a whole bunch of source maps and getting a whole bunch of file not founds. So it still isn't picking up the Java, it seems. Why not? It's the source map specifically it's not finding. Those paths, are they correct now? Slash sources, example. Oh, I see, we're missing a path segment. It should be hello world single. So this is a bit of Chrome irritation where Chrome says, yes, I know that it would be helpful to load it that way, but technically the spec says, screw you. The spec says we load source maps relative to the HTML file, which means if you have two HTML files that are not next to each other, but they're in different directories, one of them is going to have a different path to the file than the other one, the source map than the other one. Sorry, a different path to the JS than the other one, which means the JS can't bake in any kind of a relative path to its source maps. It can no longer say, in my own directory, there's a source map file here, just go find it. It has to say an absolute path or guarantee that no web pages, only one web page at a time has any source maps on it. I need to check something. Okay, we can look at that later. Nothing is actually burning yet. Okay. Anyway, now we need to modify that. This is at least a straightforward change. To say now we need to specify that our initial script file name is just artifact ID. It's actually project.artifact ID, whatever. .js instead of an extra path. That is irritating, but what? The small singly threaded server gets things really, really slow. We got a 400 this time. Note that it also isn't working. I modified the generated copy. I didn't modify the real copy. So if we look for, oops, that is the wrong button. Control P, hello world.java. Now we have this. We can stick a breakpoint here, refresh, and we're here now. We're getting ready to return this string. All right, source maps are quite slow to load from this server, so this is not how you should normally run things. Python, there are a lot of things Python's not good at. This is one of them. Let's go and modify the hello world. Just to get a quick change in there, we'll bring up this window here so we can see the recompile time. Am I adding the wrong one? I bet I am writing the wrong one. Yeah, we gotta edit the source. It doesn't work to edit the generated one. So we need to modify the app to say, we're no longer doing a document write, we're doing a document body append. There we go. So it still had to say, oh, could the byte could have changed? Could the strip sources have changed? Could the transpiled JS have changed? Let's see here. Is there anything it got to skip because of that? The bundled JS, yes, it could have changed 42 milliseconds. That's pretty good. That is irritating that it's that long for running that. But that's something hopefully we can JIT our way out of. And then we modify this file. Okay. Bundle.js is fast. I'm wondering what the startup time was. 700 milliseconds to parse those files? Wow. That can't be right. Maybe it is right. 700 milliseconds on a cold start, and 1 second for transpiled.js. Transpile has only come down 3/4 of the way, but this has come down by 70 times? Cool. Refresh, make sure that we are getting here. Hey, there's a 1 now. Did it not append? What's up with that? What was that file called? Hello.js? Still doing a document write, so that's not good. What happened here that it did not pick up that change properly? Let's take a look. We're probably going to need some more logging to figure out stuff like this. So let's take a look in Hello World single. We're looking in the bundled.js. Is that the latest copy? Yep, we're looking for CE3C4. I'm just reading the first couple of bytes off of there. CE3C4. Here's the results. And then we want to see the app itself, which is the thing that does the actual running. Okay, there's a bunch of license crap. This actually just calls say hello. Right there. This is the one where the implementation is document body append. So did it not detect the change? Or did it... Let's see what happened here. This is in hello world lib. document body append. Oh, no, it does say document body append. Okay, so this is in file B638, which is the hash of the JS output file. And what did we actually load from there? 229. That is definitely out of date. You want to talk about it, Chrome? What are you doing here? 229. It says, oh yeah, this is definitely what I would have loaded. The network tab says still 229. This says 229. We should look at the bundle app itself now, which is whatever the latest copy is. We have a little bit more trouble picking that out, but we'll do that in a minute. And here is B63. So this file is definitely not what Chrome says it is. It says it's a 200 OK, so where's the mismatch? Open new tab. Am I running off the wrong directory or something? Right here, it says it should be B638. Hello world single. Oh, you know what happened? We changed path of where we write this stuff. And I did not change the HTML file. That'll do it. So let's go and modify the source for the HTML file. Run the build once. So when you change the path of where you're going to write the file, obviously, to everybody but me, we have to also change the HTML file that references it. So why does that take forever? Why does it take 14 seconds to do this compilation here? I'm wondering if that's something we can work on too, either by feeding it more RAM. Because this is about as simple as it's going to get. This is the simplest possible hello world. All right, let's take a look here. It is not loading. This is working. No, we want hello.js. So we're treating it like a JavaScript library. Here's the document write back again. Target. Here's the directory where the HTML file exists and where the single file exists. And it says to use B638. Oh, come on, you jerk. What's going on here? Oh, but it's still loading from this path. Why? Did the HTML file not update properly? Did I not do the right magic to unpack that? Yeah, look at that. It's still the wrong path. Okay, so I just did something dumb in Maven. Not yet sure what it is, but watch me ignore it. There we go. Okay. And now if we wanted to have a breakpoint here in our original JavaScript, remember, this isn't what the browser is running. The browser is running this code here, where it's all bundled up, and each JS file is one single line. So this is the string in this Google load module with this whole chunk of JavaScript here that it's actually executing. But source maps, without even source maps, this is just the source URL mapping, gets us back to here again. Source maps gets us all the way to Java for the times that we need to call that. So if we step in, we're all the way into Java now, we can actually return that string out of there. If we turn source maps off, we still have a usable experience. Can you do it again? Okay. We still see hello.js. We still see the breakpoints there. But all we don't see is the Java. Now that we step in from our unbundled JS files, we still step into plain Java. It's going to run its class initializer. It's going to tell you so explicitly. And then it's going to run whatever the Java code was to get it to make sense. Okay, cool. We got source maps working. I would love to know why that's so slow. So let's fire up the profiler. We sometimes run into some irritation around how long it takes to launch some of this stuff. Shut that down. Okay. We sometimes see things take a little longer than we would really like them to. Here we go, sorry. Let's go here. This should be slow enough. Oh, it already finished. It said, hey, nothing's changed since it ran. Okay, let's do a clean then first. We don't actually care about any of these other tasks happening here. We just care about closure compiler. Is there anything we could be doing to make that less terrible? The bundle stuff would be nice too, but we need a real big project like Red Hat's Cogito project to really figure that out. And there we go. Now we're done. Let's take our snapshot. So basic idea here is we use the sampler instead of the profiler. The sampler does not modify each method to say, hey, please write down when you started and when you stopped, because then very small methods disproportionately use more time to run because they have to record their information on the way. Instead, we use the sampler, which is roughly the equivalent of taking a thread dump every, say, 100 milliseconds and seeing what you come out with. And just statistically modeling, okay, well, how many times were you in that method than this method? So you run snapshot when you're done. It looks like there's a specific thread here for compiler. The compiler is probably just the, hey, take the ES6 and turn it into ES3. That is, get rid of all of the module imports and exports. Just remove the modules. We don't actually go all the way to ES3. So that took only some 236 milliseconds out of 14 seconds. No, I'm sorry. That only applies when we do bundle. So I am completely on the wrong track there. How many seconds was it actually to do that? 14,941 matches pretty closely to this thread here. So this thread was just running the closure task and then the final task, which was effectively nothing. That's always good to see. The closure task spent almost all of its time here in the runner. So we created the compiler and then we ran the compiler, performed full compilation, and it broke this out between, let's see, 7.5 seconds, 4.5 seconds, and 2 seconds. So that's 6.5, 14. So we just a little bit of shaved off there in this method itself. Oh, this here. Okay, stage 3 passes. So this will get us back to our age-old conversation about typed AST, which is hopefully something we'll be able to address soon. And the basic idea here is that your first pass, you go through and you collect all your sources and you parse them into objects with structure that describe what the JavaScript has as its an API and also has as its implementation. And you type check it. So you go through a given method's implementation and say, okay, well, you said this method here. Okay, let me go check what that method does. Okay, that method returns a string. And then you said you're adding it to this thing over here. Okay, yep, that's also a string. Great. And then the next time around, when we get to the stage 2 passes, it's going to say, okay, great. Both those are strings. We already type checked that. We know the result is going to be a string. We already had that in stage 1. Stage 2 is going to say both of those happen to return constants. So just grab the constants, put them in this one place here, smush them together into one big string. Now we only have one string to worry about rather than more than one. And then stage 3 is, okay, anything else we got to do bookkeeping-wise to get all this stuff on disk? Great, let's do it. So we should be able to inline this whole method here in the same way we just inlined a bundle to produce one big JavaScript output, or many little ones if we get to that point. This is the actual parser, I guess. This is the AST work, which I guess is the slow part. That surprises me. The parse for compilation is the no, I would have expected this to be the slow part where it actually does the optimization. So I guess stage 1 passes is something we're going to have to take a closer look at. 7.5 seconds in some other thread. There must be some other thread that was running for 7.5 seconds. Here. Almost exactly that JS compiler thread. It's irritating that they're all named JS compiler, but at least the times line up. So there's this phase optimizer that's processing, and they've got a whole bunch of different phases to handle. Default pass config, some giant lambda process. Take a quick peek here. So default pass config, there's some lambda. We won't be able to easily track down which one that is, but we will be able to say, okay, who's calling it? Infer all scopes from a type inference pass. What's this one going to do here? This is going to be traverse with scope, and then inside it's going to do handle class, I guess. That's probably ES6 class rewriting, maybe. Traverse with scope. Infer all scopes. Traverse with scope. From type check to type check, and this is from type inference pass infer all scopes. So let's take a look what's happening in there. Okay, looks like we've got sources correctly installed here, so we can actually see what's happening here. Ooh, there's comments. Lovely. Type analysis happens in 2 major phases: finding all the symbols, propagating all the inferred types. And we say inferred because we don't always have all the information at compile time, because JavaScript is not, there's no types. The order of this analysis is non-obvious. Okay, so that tells us we're in danger. Probably shouldn't read too closely in here, or maybe should have an option to turn this feature down a little bit. In a complete inference system, we may need to backtrack arbitrarily far, but the compile time costs would be unacceptable. It says after compiling a 1-line app in 7.5 seconds. We do one pass where we do typed scope creation for all the scopes in pre-order. Then we do a second pass where we do all type inference in pre-order. Okay. So, okay. We use a memoized scope creator so that we never create a scope more than once. This allows us to handle cases like, here's a namespace. Now we reference namespace method, or rather we assign it. And then here we reference it. In this code, we need to build the symbol table for the inner scope in order to propagate the type of namespace method in the outer scope. I don't quite understand why that's true, except to say that we have to actually visit this, and we can't do a breadth first search and say, oh, namespace, oh, there's an IIFE here, oh, who cares about the contents? Oh, we're calling a method on the namespace. We have to go depth first into the AST and say, oh, okay, oh, look at that, you're talking about the namespace again. And then you're assigning this here. I mean, it's not immediately obvious to me why that makes these other statements true. I mean, this is definitely true. There's no question about that. But it doesn't make sense to me why we have to do pre-order. Okay, so what's the slow part of this? Reverse with scope. We lose a little bit of time at each bit of depth here. Create scope, okay, just as we find them. Traverse with scope. Handle class. Okay, so there's nothing really obvious here except, holy cow, there's a whole lot of code to parse. That's the main takeaway I get. 7 seconds is 2.5 plus, we're up to 3 seconds, call it 4 seconds, call it 5 seconds, 6 seconds. So I'm guessing we're just going to loop here. Named pass.process. Phase optimizer named pass.process. So we're probably going to get some logging here. I'm guessing we run this in a loop at some point. I'm also guessing this named pass subclasses. Doesn't seem to. So I guess we just construct a whole bunch of them. And then say compiler before pass with a name. Factory create compiler. What factory is that? That's the factory we were given for the particular pass we're running. And then we process it, delay the creation of the actual pass until after all the previous passes have been processed. Is there any reason why we should infer that this is going to run in a circle? Sorry, that is run until it is as optimized as possible. Don't move this line in the intermediate format. We create a tracer even when the tracker is null. We must also stop the tracer when the tracker is null. Otherwise, trace events, tracer thread trace events can become too big. Stop it. If it's non-null, record that it stopped. Maybe print AST hash codes, which I'm guessing is just a logging thing. I'm really curious how that gets turned on. Check determinism. Configures the compiler to log a hash codes of AST every pass, only intended for internal development. Okay, well, that isn't us. Maybe run validity check. I'm guessing we don't run that, or if we do, it's cheap or free. Hey Mojo Rising, thanks for joining us. What kind of thing could get assigned to here? Run in fixed point loop. Okay, so there is a flag we could be setting for that to say whether or not we will run in a fixed point loop. I'm not quite sure who's going to read that yet. We'll dig in there. It has its own check, but it's not clear to me. Oh, here we go. Dev mode, every pass. If dev mode equals when to do the extra validity check after each pass. This implies we're looping. What's the normal value for dev mode? Let's see, it's assigned here as off. It's assigned here as dev mode. It's assigned here as JS comp dev mode. We're probably coming in through this path, which is off. Okay. Do we even have configurable options for this? We do. It defaults to off. Turn on a very slow extra validity check for use when modifying the compiler. Oh, this isn't dev mode for a developer developing their JavaScript and running the compiler. This is developer mode for a compiler developer who is tweaking the compiler and wants to say, hey, did I break anything? Okay, so we would effectively never want that. Let's back up to where we were. I would like to crawl up the stack of step or two and see where we loop. Oh boy. Well, that is a lot more than I was expecting. Let's go specifically to phase optimizer.process. Top one. For each passes, run that pass here. When looking at this code, one can mistakenly think that an instance of phase optimizer keeps all the compiler passes live. This would be undesirable. A pass can create large structures that are only useful to the pass, and we shouldn't retain them until the end of compilation. But if you look at named pass process, which is where we saw the factory call, the actual pass is created and immediately executed, and no reference to it is retained in phase optimizer. And actually, then they repeat the factory call here just in case you won't go look at the code, which is a thing, I guess. All right, this in turn is called from compiler check. Create phase optimizer. Consume some checks or something. Here's a list of your factories. Here's your passes. And then we call that process. So it makes it look as though each pass runs once from this perspective, which is not what I would have expected. This in turn is called from perform checks. If you skip non-transpilation passes, we just do this. We don't care about that. Perform checks is only called once from here in the stage 1 passes, and that's where we're in. So how does it run until fixed point? Where's the run until fixed point? Because this will just null it out to let it get garbage collected. I mean, eventually. Let's see here. For each pass, we process the pass. This is going to be the named pass that we just talked about, which has a process method, which is going to say, hey, create the thing and then process it. So where does the fixed point stuff come into the picture? All right, so we got a whole bajillion of these. Combined compiler passes took some 400 milliseconds. COM, there we go. Node traversal, which is just basically saying, hey, grab the root and walk it with this as the visitor. And this visitor will say, hey, do I want to look at this or no? And I guess there's multiple checks it does along the way. And I guess this is constructed around many callbacks. We could probably trace our way up, figure out who is making all those instances. Combined compiler pet, nope, that's just a helper constructor. Combined checks, there's a couple of these, I guess. We're not doing that, I know that. We don't need docs in a production build. Check control flow, that one we are likely to do. So if you have disabled some of these things, it will turn off some of those aspects. Great. Can you loop me in? What are you doing? Is this someone else's code? Yeah, this is Google's closure compiler. This is what they use when they write lots and lots of JavaScript and want it to compile out, and what they have used for like 15, 20 years, somewhere in there. A long time. Anyway, Webpack and all those ESBuild are slowly reinventing the wheel that Google's been using forever, TypeScript even. The basic idea here is, sure, you can get pretty fast by just taking all your JavaScript files and smushing them all together, and even removing white space and comments and junk like that, and maybe even rename some local variables. But this goes a step further and says if you have types in your JavaScript, and you are clear about this, and this looks a lot like your TypeScript type annotations, we can figure things out about your code, and we can optimize it. This predates ES6 modules, so instead of doing imports and exports, we have an actual export assign syntax, and we have this, hey, declare my name, and here declare what I'm going to import. It actually looks more like Java or C# than it does like TypeScript, because again, it comes from before all those things. So anyway, you feed thousands and thousands of files to this. It is going to go through and say, okay, let me parse all those files, understand their types, try to use those inferences to actually compile things out. So we have this file here, we have this other app here. We wrote some Java, the Java file is this one, which has to get compiled to JavaScript. The JavaScript file can be found, one moment please. Nope, that's the single output, so we actually don't have it available right now because of how I ran the compiler. Anyway, compiling all those together, and the bits we're using here to turn Java into JavaScript are keeping all this type information along the way, saying, okay, well, clearly this extends from object, and which means it has hash code methods and equals methods, and it has to behave well in a Java world, because we could use this as a library for some other Java code. So it has to build all that code in. And say, hey, here's a call that could be called from JavaScript. I want this object to be treated as though its public API is reachable from JavaScript. Combines that with those other JavaScript files we looked at and a whole bunch of JRE emulation, so a good portion of Java itself is emulated. And it compiles it out to just enough bookkeeping here to say, okay, we have a IIFE, which is a immediately invoked function expression. And inside of there is just the, hey, there's a function here that we're going to make. I don't know why it exports this. That's a little weird. And then it actually runs the code here of hello from Java and JavaScript. It rewrites the Java all the way down. What we are doing here is we're building a plugin that wraps the, hey, take that Java and compile it to individual JavaScript files. Not very efficient, but strongly typed. They've got all their type information there. And we've glued that together with Clojure compiler to say, okay, take all those JavaScript files. Here's 10,000 JavaScript files, which came from some 5,000 Java files, and compile that down as much as you can into some very small output. It takes a long time to generate the output, but on the other hand, it's very, very efficient once you get there. So the project we're on here is the code that lets a standard Java Maven project say, hey, I've got a bunch of Java files. I want to have some very small Java code. And we are looking right now at performance because something is taking a little longer than I would have expected. In fact, quite a bit longer than I would have expected. So I'm profiling the compiler as it goes and saying, okay, so what is happening here? Why is it running so slowly? Is it necessary to do that? Could we turn off some features in the compiler to make it a little faster? The dev mode that we have here is fast enough to be pretty good. So we've got this dev mode where we say, I don't need the debugger to show you. So we just say Jackal watch, which is going to go through and build all of the outputs and construct bundled files, which is the equivalent of, not doing much more than just packing files together. Now we'll be able to see the sources. As soon as IntelliJ gets its act together, there we go. So our Java file now was compiled into two different JavaScript files. This is the important one now, where it has all the structure stuff to say, well, every Java class extends eventually from Java lang object. So we've got the bookkeeping there for that. We need to work out how exactly do you run constructors? How do you expose constructors to JavaScript if you do at all? Static methods, how are they going to behave? Down here is normally where we would have interface implementations if we had any, and then the mapping back to source maps. This other file here is just the bookkeeping of how do we track circular dependencies, since ES6 doesn't do a great job with those. And then each one gets bundled like this, so our own project only gets baked into these individual 6 files. And it made one line for each one. We've just spent some time making that efficient to make this change only when necessary and not to reparse all the files whenever any one file changed. So this just has to concatenate the files into one piece. It runs very quickly. So if you watch down here, this is the check to say, okay, if I change this file here and I change that 1 to a 2, because I'm just changing this often, hit save, it's rebuilt. And the actual work of taking all those JavaScript files and putting them into one, we would like to be faster, but this is getting near where we need it to be right now. For the entire JRE, we've got this giant file over here, which is going to take a while to open. It's several megabytes. I couldn't tell you exactly how many. So here's our running. Oh, I turned off the server. Let's turn the server back on. And then where is the HTML file? Oh, I deleted it because I'm a jerk. Let's just copy that over. There we go. So breakpoints are working just to show that source maps work properly if we wanted them to. The number 2 is obviously visible there, but the important and terrifying part is that this JRE is 4 megabytes to emulate all of the various bits of Java that we want to share back and forth. So this will eventually be used in projects that are much, much, much larger than this. The GWT project that exists today is something that we work on too, to say, hey, how can you compile all these Java files down into just one piece of JavaScript? This is meant to pick up some other advancements, some other improvements that the Clojure compiler can bring projects like ours. So we don't care about speed here much. We're working on speed. We still care about it being better, but it's not the main thing we're after right now. Where's that app? Where's that hello.js? Let's see, it's in my source directory. Hello. So if we change this contents here to put question marks or something, hit save. I mean, probably can't even get over there quick enough to see it. Refresh this. The new output's coming up there. So we're really not too concerned about this part here. The part I was concerned about is the fact it was taking 14 seconds to run the compiler. We narrowed that down to 7 seconds in stage 1 passes, which is where you go ahead and examine all of the files for their types. And then stage 2 passes where you actually optimize to produce, the almost nothing. So we did the first one. I don't really see anything we can turn off right away. I don't understand this well enough. This is going to be a learning process for me too to get there. But this is one particular default pass that just happens to be taking a long time, 2.5 seconds, to do this this infer all scopes. And I'm not sure if it's slow because it has to check each file once. Anyway, we have some tricks we can do to make this faster. There's a thing called typed.ast built into the compiler that we believe Google uses internally. But they don't really demonstrate how to use it. They've got some flags you can use to turn it on. And they've got just a tiny, tiny bit of docs in here, but a lot of the docs are, hey, this is not ready for prime time. Please don't use it yet. Let's see here. Where's that particularly helpful one? Nope, doesn't really say. Init typed.ast file system, speed up builds that don't run type-based optimizations, skip type deserialization. Okay, we can't skip that in our cases because we need all the optimizations. But in theory, this would allow the compiler to say, hey, I've already seen that JRE before. I've already done its typed checks. I know it's type safe. I don't need to run it again. And then only run the next stage, which is the performance optimizations. So stage 1 passes are, let's start at the actual beginning. Parse for compilation is go look at all the JavaScript files you were given, read them into memory, each one, and figure out where the functions are, where the field assignments are, where the local variable assignments are, where the method calls are, and build a big model about what the program looks like. Stage 1 passes is, okay, go through that and figure out what, when you are calling methods, what was the return value? Okay, now you took that return value, you stored it in a local variable, and then you called another method with it. Was that method expecting that kind of value? Okay, great. We don't need to do anything magic there to make it work. Stage 2 passes is, okay, so inside of that next method, it says if Boolean you passed in, or if string equals other string, then we do this work here. But I can tell that the method you used to assign to a local variable before you call this other method is always going to return true. So I'm going to just go ahead and say this local variable is always true. Okay, now I'm going to say this method's parameter is always true. Okay, now I'm going to remove the if check. We no longer need an if check. Improve it that way. Stage 3 is about localization as far as we can tell. So it takes almost no time at all. It's just how do I finish all this optimized JS and write it out to disk so somebody can use it. So this is our next target for how we're going to optimize things. And between any one of these passes, we can write a typed.ast to disk. The question is, how much of the typed.ast can you extract early on in your build? So before you even know about the whole program, when you just know about one library, can you extract all of the type information? And can you even begin to optimize it? Stage 2 would be optimizing it. I think it's very unlikely we can do anything there. But stage 1, where in theory, we are just taking a look at, let me just open it up real quick and show it. Stage 1 consists primarily of error and type checking passes. Parse for compilation must be called before this is done. The caller is responsible for calling generate report to generate a report of warnings and errors to standard error. See the invocation in compiler for a good example. Okay, so yeah, it's just going to do this perform checks call. The perform checks, in theory, if you have perfect code, shouldn't ever matter, I think. It may, however, propagate some things like scopes, and I think that's what we're looking at here. We run check, we run process, and eventually we work our way down to, I'm sorry, I have to look at this again to find it. Default, nope. Infer all scopes and type inference pass. So this is where this is probably a little before you came in. The steps it has to do here or why it does them. The question then to us is this necessary for later passes? Is this going to be something that we have to keep track of? What happens if we skip it? Do we break anything by skipping it? Or can we just run it ahead of time and still get all the benefits of it? So that's again, outside of the scope of what we're doing right now. Let's go ahead and shut this down, take a look at our changes, start committing those, and looking at just wrapping up this part of the project, which is the, hey, if you only change one file, don't reparse every single JavaScript file in your project. Once we have awesome tests for that. Oh boy. We're going to need to work on that next, making sure we have some tests for some of these things. That should probably be the very next thing we do here. I don't like that. I just checked in a bunch of commented out code. Config disk format in task summary disk format. Yeah, let's just junk this. Clearly I didn't need it. This is all just to say, hey, here's some stuff we want to write to disk because we're going to read it in a later pass. For example, if incremental is cheap, might as well always do it. If not, only do it if Marcus suggested be a good idea. However, if this flag is false, incremental should never be attempted. Could be a bug in it too. So this is, we talked about this a little bit ago, but if it's true, if it's cheap to write metadata for the next pass, just in case it's turned on, we should always do it. If it's false, hang on, that might not work. Yeah, that's going to be a problem because we don't actually check. We will treat that as, we'll get to it later. The problem is when you change a configuration property, we invalidate your cache and we say, okay, I'm not going to use any previous input. We treat it as totally new, so we always do a fresh build. And it will say, hey, you changed a config setting, so I'm not going to mess around with trying to use the old output. We'll get there. This is not the kind of thing you want to flip on and off. This is a kind of thing where you flip it off if it's expensive and broken. Or mostly if it's broken. Looks like we never used this. We should go back and fix that. That is in input. Oops. I think other people are... Oh, no, she's still asleep. Okay. Got a 2-year-old who might wake up any moment here. This is the wrong input. I have 2 things called input, the interface and the implementation. Probably need to rename that. It made sense at the time. So this is how we do change tracking to say, the last time you built, you had a file. It is now removed. Here's the source file it was at, the source path it was at, so you can keep track of it. If it was added or modified, this optional will return the new path, and you'll have the source path to where it was in the old stuff. But if it's removed, this will be empty. So that's just a simple API to say, hey, how do we generally track this? Nope, that is bad. We don't want to do that because it removes a bunch of our tests. We should check our imports here before we check this in. Oh, hey, that looked like commented out code. No. There we go. Yeah, let's go fix that. That's in the closure bundled task. So we've tried this a couple of times. It's taken me a couple of weeks to get to this point. A couple of weeks of, work on it, skip a week, work on it for one day, skip a week, work on it for another day, skip a week. We no longer need that anymore. We were going to try adding more memory and seeing if more memory just magically made it faster. We should try that still. Because it's quite possible, given what we read about each pass building on its state every pass, every time it runs, and it apparently can run in this. We didn't check the fixed point thing to understand what's happening. Anyway, talking too fast. Apologies. We might find that that's a better. Oh, hey, we gotta fix this. To do before merge, write this to the log. We'll come back and fix that. This is a hacky draft for how Jackal could work. We probably should revert it. I'm just not going to check it in for right now. Strip sources task. Yes, we probably will check that in this first pass. Moving to Java 11. We're not going to do that right now. I'm about to run out of space here. Incremental tracking. You have a fixed stream schedule? So happy I found an actual Java stream. Not right now. Holiday season is going to screw us up a little bit. We are 2 main streamers at this point. I'm really hoping we're going to pull our friend Ahmed into this too, but Justin and I are the 2 main people on this channel. Usually he's Fridays, usually I'm Wednesdays. And it's pretty much all day when one of us is going. He's talking about moving to Tuesday. Justin, I don't know if you're around, but are you still thinking about moving to Tuesday and sticking there? Anyway, this is Java, but we're doing almost all of it in the browser. We've got other projects that are actually real Java on the server. This is a project using Juke. We're going to start streaming it in the new year sometime, probably around February. Just to say, hey, we've made all this progress. It's worth talking about and showing off a little bit. But for the most part, the work we are doing is saying, hey, we've got large, complex problems to solve. TypeScript is better than JavaScript, but still silly. So let's use Java to express our program, and then use a compiler to transform it into efficient JavaScript. All right, and all this is open source, by the way. This is all available at our GitHub. Oops, that's not the GitHub. just in case you are interested in digging in a little bit more. Vertispan is our company's name and our channel name. Jackal Maven plugin. J2CL is Jackal. Apparently, it's a thing in Google that you have to pronounce all acronyms or initialisms as if they were acronyms, even if they don't have vowels. You get some pretty weird sounds out of that. Anyway, J2CL is Jackal. Jackal Maven plugin. We've been a little quiet lately. The last merge was November 7th. Got a couple pull requests that are open. That is just wrong. That's not going to work. Anyway, we lots of issues, lots of bugs. Fairly stable though, so we're working on it. And then we're gonna get rid of that. And then I think I'm just gonna push it to make this the continuous integrations problem. And it will then build this. Let's see, am I logged into GitHub? Yeah, I am. So we can do that right. Probably more junk we need to clean up in here. Been writing this very slowly, as you can see, over the course of a month. Been thinking about it for far, far longer. We'll let continuous integration run. Let's do a quick self-review then. Jeez, I wish I could type. Hmm. Finally wrote docs there, I guess. Let me check, make sure the small one is still sleeping. Is she? I can't tell. Nope, I hear her out there. I guess she's awake. It just looks like she is. I don't know why I removed that period there. That's irritating. Maybe make it into heading or something. All right, so one of the concerns I have is when do we throw away, when do we not allow a build to use the cache? Oh yeah, gotta write those tests. I just said that, didn't I? Okay, so here's the part where we say, here's your latest result. Let me make this a little more readable. No? Okay, fine. So this is a lambda, that way we only run it once. And it will only be requested if the task that's running says, hey, I can build incrementally. Could you tell me what has changed since the last build? So that way, for a task that can't even do this, we don't do the extra work. So first we say our previous input came from, hey, go get that disk format. Make sure that we find the, oh, that better be, well, we'll see. Make sure we filter it down to inputs that have the same project key and inputs that have the same output type as whatever input we're looking at right now. I and input. Let's see, input comes from where? Here. So this file must have been read only once here, and then we're just iterating through its inputs and matching them to the particular input that we are examining here. Might be better to have a lookup for this. It's possible that it won't ever matter if performance is good, so we can ignore it. Previous input is present, so if we found some previous thing, then we need to say, hey, here's what happened there. What happens if you don't find a matching input at all? Previous input is not present, for example, then we go to here. So this is per file, I guess. And then we swap out the old, hey, execute the task with just this output directory and this log, with the new, hey, execute the task with the output directory, log, and the last output directory we found, or else null. So we ask the latest result here to tell us if there was some existing output. What we don't do very well, though, is say, hey, this had an input that's no longer present. So the existing inputs, yeah, here's the problem. Okay. So if you have 5 dependencies in your project, for example, and you remove a dependency, then when you run the task later on, it's going to say, okay, you only have 4 dependencies here. Dependency 1, yep, that matches. Dependency 2, yep, that matches. Dependency 3, yep. Dependency 4, yep. It is not going to recognize that the last time you built, you had a 5th dependency. So, and it's not going to be able to say, hey, something was removed. This may not make sense anymore. Okay, so we'll come back and fix that. As long as you don't change your dependency graph, your one Java project depending on another Java project, it won't matter. Also consider if last successful path should be null for final tasks. Yep, we're going to leave it as null for right now. Final tasks are when we say, okay, let's copy the output so that we can actually run it. we're going to need to go through and find other log junk and fix that up. This will all be protobuf later. Incremental enabled, the local build cache where we keep track of the more recent builds. This is a big one. I don't think there's much we got to do in here, except check the imports, make sure they're still good. Yep, write that to the log. Yeah, we're going to have that as a follow-up task. Basically saying, how do we avoid rewriting the entire file? And looking at each file and parsing each file, because this check here, this append, still costs something to go through and rewrite. But it's not as much as, parsing the JavaScript. Need to remove these, since it apparently works without them. And then Jackal task, we're going to need to junk that commit entirely. Strip sources, this one is much simpler. It's pretty much one-to-one, and then we'll land that separately too. Okay. So we'll come back to that. Let's just on our own check imports real quick. Make sure these are somewhere near sane. Yeah, they're not. All right. Let's see, what else did we change? We changed the strip sources task. We changed the watch service. Probably the build service. These are all in the same package, though. It'll be a little easier to find them. I don't think we changed this. Nope, didn't change that. Task scheduler, probably changed this. Imports are still good. Don't think any of these were touched. I think this was slightly changed, but it's pretty much the same. Not in any meaningful way did it change. Input, oops, not dependency input. I don't think we got any garbage in here. Let's check its implementation. Oh yeah, got some extra junk in here. Okay. We'll keep an eye on that build. Maybe we go ahead and make a separate branch where we're dealing with the Java 11 stuff. So git log, grab this commit here, co main, git update, cherry pick, commit. We might have some other cleanup along the way we can do, like looking for collectors and junk. Yeah, all of these can pretty much be rewritten. Unless we try to mutate the list. So in Java 11? Yeah, in Java 11, we got a new toList method. Oh, I'm wrong. That's Java 17. Well, never mind. I guess we can't rewrite any of those. It makes it immutable, though. Lets you do to immutable list. To unmodifiable list. There we go. So we can go through and we can tweak a bunch of these to say, hey, now in Java 9 to unmodifiable list. We've dropped Java 8 support. We used to have it. We don't have it now. Let's see, this is going to return a list, which is going to be entry points. This is dead anyway. This should really be removed. We'll just go ahead and bulletproof this and come back soon and remove it. Function may not return null, but it's allowed, but it's not allowed here. Function may return null. Uh-oh. Yep, that would be bad. So the unmodifiable list is not allowed to have nulls in it. So I guess we need to check for nulls on our way through. Oh, it doesn't understand that this is going to catch it and throw. Let's do this differently then. We'll expand to a lambda. And we'll expand that to multi-line. I think node has a reasonable toString. Node is a what? So this is how we read from... Oh, it doesn't. Well, crap. Can't always read strings. We can't be relied on to read anything there specifically. So we'll just go with that for now. That should be clear enough. Or, hey, you broke it. Checks. There we go. Interesting that this can't return null. It can. So why aren't you giving me crap for that? Oh, because we could never have one here? Is that why? All right, so this is how we read from our Maven configs and figure out that when you're running a build for the whole project, you're saying, hey, I want to run everything in dev mode. Please don't make me compile each thing separately. It goes through and it finds the details about the build and just does it from there. Yeah, it's going to still return a result of null if it fails these. It is interesting that it thinks this is null safe. Well, whatever. We will now no longer be null safe. We will blow up if there's a null in there now. All right, let's see what this next one is. Entry set stream the look only for pending tasks, get their entry, and then return an unmodifiable list. If canceled, return empty list. Otherwise, I'm not sure that's safe. We might modify this for each. Where's our other reference to copy? It's not a copy. Well, it is a copy now, but it didn't used to be, I guess. Tasks get pending list. Yeah, it's the only reference. Okay, so now it's just a loop. Huh, interesting. I named that poorly. Let's clean it up while we're here. It says iterating a copy in case something was removed while we're in here. So we're going to change that comment too. Don't even need that anymore. Filter based on work which has no dependencies in this batch. It has no currently pending. So this is how everything parallelizes. By saying, okay, I've got all this work to do in order to build this thing. Let's go find just the things that nobody is depending on. And then for each one, we will see if we can build it, make sure that there's nothing, make sure it's not already finished, and make sure all of its inputs are finished. Filter based on work which has no currently pending dependencies. Is that right? Filter, come on, what's it supposed to say here? Filter based on work which has no dependencies in this batch. Okay, so this is kind of poorly phrased because it's this part here, and then we also do this here because we have to do these ready checks under this lock because we're just using a hash set or something. Okay. All right, so here we have paths. That's going to be unmodifiable. All of our builds are passing. This is kind of unusual, but I'm not going to argue with it. I guess we can clean that up. I like it that way better. So you're wrong, IntelliJ. You're wrong. Did I scroll too far? There we go. So now this scope, does anybody call this and expect that they can modify the result? Almost everybody streams it. Streams it once, streams it a second time. Let's pin this search result and tab, and then find all calls to this. And check each one to make sure that, okay, that concatenates the streams, that concatenates the streams, that stores it, and then it streams it. No, it only streams it here. Why don't I stream it up here? Why do I stream it, do some things, make a list, and then stream it again? Because this is the first time it runs, and this is inside the lambda of the task itself. So this is setup time, and this is when we actually run the work. So this will be called many times. So every time we get it, we're going to take that list, iterate through it, concatenate its output onto this. Cool. Concatenating streams, stream and filter, stream or concatenating class path headers. Does anybody add to this? Nope. Nope. And the last one, nope. Streams and, okay, so probably we could just actually make it return a stream and not even collect it anymore. I think that would work. Let's do it one more time here and just see if we can do that. That's kind of a breaking change. Let's not do it right now. Let's do it later. Let's for now just change this to be an unmodifiable list. Hey Dimitri, welcome. I just pushed a branch for incremental stuff because it seems to work for closure bundles. So if you want to give that a shot, build this branch and see if you can run that on a great big project and see if you actually notice a compile difference. Strip sources will be incremental, and bundle itself will be incremental for parsing JavaScript files. It's going to write some great big JSON files to disk, Yeah, if you wouldn't mind, I'd appreciate it if you could give it a quick run. I'm just factoring out one other patch there, which said, hey, we got to move to Java 11 anyway, so let's just go ahead and make some of these other checks. Make some of these collection calls unmodifiable, since it's just a little bit of a different call. Because then in Java 17, we can just call .toList on the stream itself. So let's see here. Project set source roots. Nobody should ever modify that. That would be terrible. So unmodifiable list. So just some tidying up, as long as we think the rest of that is working. The patch is not ready to land yet. It needs tests, and it needs some other cleanup like logging, and it needs to be rewritten to use protobuf instead of JSON, or something else that's going to be a little less gross. I could probably live with JSON. We'll see how much I care. These, oh, hey, look at this. Get source roots and then append this. So that's disgusting. Test get source roots, add all. So these should be concatenated. Let's rewrite that. That is a really long line. Who let me do that? Okay, so now we stream, filter, collect into a function identity, and a collect the items into a list. And nobody has any business changing this. So we'll change that to be unmodifiable. Nobody should be modifying that. Okay, so this is modify. Well, no, we iterate it. While it's not empty, iterate it. While it has next, why do we need a remaining empty check here? While remaining is not empty, we take an iterator and we remove off the iterator. The iterator will remove from the collection, so we can't change that. Okay, that's deliberately modifiable then. We'll leave that one alone. Output to copy is used down here. We just iterate it. Shouldn't matter, because we're just walking it. All right. That should not be modified. That'd be bad news if you're cheating in here and rewriting that. Still going to come back to this and get this to work in newer versions of Java, but not today, my friends. This may conflict. We're not going to worry about it. JS stream. We never modify it. Cool. Why do I do crap like this? Oh, I know why. Because you can't do things that might throw an exception instead of a for each call. Leave it alone. It won't matter. There's no way we could accidentally screw that up. Singleton map. That's interesting. I don't remember writing that. And we're going to delete it pretty soon, so it doesn't matter anyway. JS sources is consumed here by map from inputs, which won't modify the original. It'll just remap it. Okay, output to copy, same thing as before. It's just going to iterate it later. Hey, translations. I'm certain that won't be modified, and if it is, we got lots of tests. Thank you for that. This is the same as before, roughly. Yeah, it's not modifiable. Just double check. Double check where we consume it. Yeah, we just pass it directly in there. There's no way that would make sense. Map from string to list of string. Oh, what a jerk. Who wrote this garbage? Yep. Won't be modified. Should be fine. I can't imagine they would. Yeah, no. We just stream it right away, so it won't matter. Let's make this readable. We got 2 streams, and then we combine them and then make a single list of them. Finally, nearly done. Probably should have a utility for some of this stuff. Yep. Like just mapping the whole set of files to paths or back again. Temp. If is empty, iterate, but no tracking there. Let's go ahead and rename temp. Let's see here now. We're going to say this is all XTB inputs, XTB files. Turbine. Did we enable turbine by default now? I'll check that. No. Dimitri, if you're still around, we said we were going to enable turbine by default now, right? It was the last build was... Yeah, now that it's in 17. Okay, so we can change that too. I'll come back to that. Cool. Immutable copy of, it's already immutable. You shouldn't have to copy it, you jerk. If instance of immutable collection, then we just grab it. But what if it's a Java immutable list? Well, you're a jerk, I guess. I guess Turbine will make a copy of it. Let's see here. Yeah, there's no way you're going to modify that. That would be awful. Duplicate relative paths is empty for each, and then just dump them. Let's just don't be a jerk. Yep, that's fine. Yes, exactly. And I'm finishing that up now. We've already moved to closure, so we have to use it anyway. So now I'm switching over to Java 11 as our compile output, and I'm also switching on some other Java 11 features. Okay, so let me make a commit for this. Okay. Okay, let's turn on turbine by default. Mm-hmm. Oh, I see. Um, okay, so now it's still enabled if you use this flag. Oops, I checked this all in on main because I'm a terrible person. That's surpassing remarkably well. We haven't had even a single failure today. I have to make a better pull request message for this, but that will at least get us some quick CI here to make sure that works, since it takes like 20 minutes to do that. 23 minutes so far, and we're still chugging along. Windows and Mac, it's a race. Who's the slowest? Okay. Got a Slack message waiting for me. Let me see what that's about. Okay. I think I'm gonna give up for a little while, guys. It's been about another 2 hours, and I got a lot of snow to shovel. and it's stupid cold out there. 1 degree. We're up to 1 degree. It's only like 15 below zero in Celsius. All right. The Mac seems to have won the race. Windows is still the slow one. Here. We'll keep an eye on this. This incremental one is going to take a little while longer, but we can get the turbine update done for now, at least get the users on 21 snapshot up the turbine, get things a little bit faster, and then hopefully this will go a little better here. With this working, this is going to be another push for me to get typed AST back up and running. And hopefully, Dimitri, for you, this will be the push to say, hey, let's get Jackal fully incremental. I did leave the Jackal where is it? Oh no, Windows failed. Wait, what? It said these all were passing. Look at this, incremental API and disk format for, oh, the next build failed. Okay, that's dumb. We'll figure it out. Anyway, Dimitri, as I was saying, there's some changes in here. The Jackal task probably only needs to be thrown away and rebuilt. There's just one single commit for that. I encourage you to do a much better job than I've done there so far. But now that you've got 2 examples with the API, it should be not straightforward, but it shouldn't be terrible to build that. Oh, look at you. You are a jerk. Failed. Build code exited with code 1. All right, we'll look into that later. The static resource is crap again, so I think it's HTML unit being a jerk. My hunch is we're going to fix this by just stopping using HTML unit and switch over to actually running Clojure in Docker. I'm sorry, Clojure. WebDriver, Selenium in Docker, and just run a real Chrome browser, because then we can actually say, hey, you just need to run your tests against a real browser. Let's not mess around with this. Failed. Yep, it's happening here too. Increment. Oh boy. Elemental failed. That might be a real issue then. Right thing there. So let's do a Elemental 2 project. Let's see if this actually generally fails. And then we need a whole lot of tests. I mean, you and I have talked about this before, but we need some. Oh yeah, we are in bad shape here. I broke something. Okay, so that patch will have to wait until we figure out what's going on here. I might have energy for that. I just don't want to switch to a whole new task. It's trying to modify some collection that it shouldn't. Missing task factory. Huh. I guess I configured that wrong. That's weird. Strip bytecode headers is implemented by Turbine. Its output type is strip bytecode headers. It is registered as an auto service. It should be iterated for this. And it returns default. It should just be the word default. Did I typo default? DEFAULT task name should be default. Oh, I know what happened. We have the elemental build actually using Turbine. So the error message is bad. Here we go. Yeah. Who checked this in? What jerk checked? Oh, you did. Okay. All right. Well, we can remove this now because it's on by default. Sorry. I don't mean to blame you. Because I thought I did it. I thought I checked it in for something else unrelated. That's going to rebuild. I'm gonna quit this, I think. It's snowing harder now. Always what I want to see when it's time for shoveling snow. But I don't think it's going to get any warmer today. I think 1 degree is as warm as it's going to get. We might only have a couple inches of snow left today. Jeez. What do we got? Yeah, overnight, 2 more inches of snow. Okay. I'll go move what we got so far. Okay. With this out of the way, hopefully typed AST will be back again. Grit CLDR has been bugging me from another project, so I might get back to that and see if we can try again to get closer to make more sense. And typed AST. Yeah, that one's important. JS interrupt generator, getting some better output from that. I don't know, we got a lot of stuff to do. So, Dimitri, you missed it earlier. I don't know if you care. You might care. I played with the GWT object formatter, the Chrome object formatter API, and made JS interrupt types for it, and I tried to make a little implementation that would let GWT objects like collections be logged. But there's just a lot of weird edge cases inside of how it all works. Yeah, I'm going to try typed AST again, just because typed AST seems like it should make more sense now that I've taken the compiler apart to do the bundling stuff, but we'll see. Obviously, that might go horribly wrong. Anyway, I don't know if you've got any complaints from your people about debugging in the Chrome debugger with GWT objects and collections, but I just did some special casing for primitive arrays and for Java arrays, and then also lists and maps. Right now I've got some special formatting. Collections will need something too, and then inevitably I'm going to have to dig into just plain old Java objects and get them to handle something special. But I'm not sure what that's going to look like yet. So anyway, it will work for Jackal as well. Yes, all of this is just vanilla JS interop. The API is just a really simple API. We have to grab onto the self, and because in GWT 2 we've got an iframe, we've got to talk to our own iframe and say, hey, change my formatter, because setting it on the window doesn't work. This API is just not my favorite thing. And then the one other thing we need is this JSON markup, which is actually an array. JSON ML is a thing, apparently, so I just made some utility methods that make it behave like a builder by saying, hey, if you've got an overlay here that returns an OL, it just calls element, and element in turn calls the underlying native method of, where you take a tag name and some attributes, and then we just add more children on the end. And I just continued on in that vein of saying, okay, how do we need to append objects to make them make sense in this weird object format that they insist on. They have good reasons for insisting on it, but I'm still going to give them a hard time about it because it's silly. Anyway, so this is again just vanilla JS interop, so nothing special has to happen here. The self object is just, hey, go grab self out of the window, because there is no actual way to get the global this easily in GWT, because it always goes to the root window instead of your own window. So that's not helpful. All right. How am I going to ship it? I'm going to make this if it works. Okay, so this is sketchy code, mostly because the underlying feature is pretty sketchy. If you want to watch the stream from this morning, I ended up getting the Chrome dev tools to debug the Chrome dev tools to figure out what they were doing. I tried to dig through their sources to figure out how they were doing it, and they just have some custom code that handles this. So eventually we figured out something that works pretty well to say, hey, just generate some kind of content. Here, let me pull it up real quick. Right, I've already got a debugger going somewhere. 1 second. Not a debugger, a server. All right, so we are in this debugger right now, and this here is an array list, and so now it logs array list size equals 6. And you expand it, and it shows each element. We finally got to the point of showing the numbers. They're not purple anymore, like they are usually in Chrome, like how these are purple. but it's actually 0 indexed instead of 1 indexed. And you can expand some of these nodes. Now this is weird that it's doing it all in one list here instead of a new line for each one. Anyway, I can use the debugger to figure out what's wrong, but I'm not going to do it right now. And I don't have hash map key value pairs very nicely. It just does pairs like this to do key value pairs. And then primitive arrays also work. And then this is a double, this is a Boolean. Obviously those box properly. This is actually a array list of capital I integers. So it unboxes them properly. It correctly says, hey, you're an integer, so let me unbox you and render the number. There's just custom boxed primitive formatting that lets that work properly. And then this is a hash map that has itself as contents. So in the value is the same hash map. And so you just recursively see that same hash map. Or you look at the second entry. It's scrolling, it's just something weird. Second entry has a key of an array list and a value of a string. And that seems to work properly. So to turn it on, you add this to your project as a dependency. If you're using GWT2, you need an import, and then you have to go into settings and go to enable custom formatters. Settings, preferences, console, enable custom formatters. And if you turn that off, we go back to plain old arrays, $array list, which has an array inside of it, and the array list is numbered. I mean, it's certainly readable. These shorts make sense. It just has the castable type map and type marker and class, things you don't really need. This array list of integers looks like box integer with numbers on it, which again is still usable. And the hash map gets a little funky too. You got to say, okay, the string hash map has one entry in it, and the hash code map has a different entry in it because I deliberately made heterogeneous key types just to be irritating. So here's the key, and then the value is the entry, which has the actual value and the actual key here because it's a hash code map, and nobody wants to look at that. So if this works out, we can just make it as a separate jar, ship it to Maven Central. Someone's going to need to make this a little better styled because it's crap what I've got now. Yeah. And then also figure out the edge cases of, okay, well, what happens if you put Java objects instead of JS objects and JS objects instead of Java objects, because this whole key thing doesn't really work properly around that. We have to, once we own it, we have to keep on owning it all the way down, which means you might lose your prototype, which means you want to turn these things off. I don't know. I think if you got to dig into the JavaScript, you just got to turn it off. This has got to be a only use it if you need it feature. Also, it never logs properly to the console. There's just this really irritating feature about if I do data 0. So it actually already logged it. Oh, you jerk, it's going to work. Oh, no, it's because I turned it off. Hang on. I thought it was going to work this time. Show Dimitri, and then it works. Let's try it again. Okay, so it doesn't log it with the little expand thing, and we get this weird error. Uncaught, cannot find context of specified ID. Okay, well, that's weird. We're in the breakpoint. If I hit enter, now it renders it, and I can expand it, but we also get sometimes it just says, oh, well, 0 and 1 go on the same line. And then 2 goes over here, and you have to expand over there. I don't know why it does that. Sometimes it does it, sometimes it doesn't. We haven't figured out a consistent way. It's because there's a div wrapped in a span, and the sizing matters. So the sizing when you first expand it matters. Now it's good. Expand it. Oh, hey, now it's breaking. Because they're putting divs and spans because they're jerks. But why doesn't this roll over to the next line? Nobody knows. Anyway, I hate it. Yeah. I'm going to take off and go shovel some snow. And I'll see you in about 3 weeks. I am out the next 2 weeks. I'll be, on Gitter and online and stuff. But I'm not going to be streaming. I'll be away from home. So I won't have my usual setup. And I think Justin's off too, at least the next week, probably a week after that. And then in the new year, we'll be back again and picking up all this stuff. So thanks, everybody. This will go up on YouTube. We've been putting the last couple ones on YouTube. Thank you, Justin, for making that happen. Yeah. Have a happy new year. And everything else in between.